Hello guys, welcome to the continuation of Python tutorial in predicting Boston housing prices using machine learning. So let's start coding. We need few libraries for this one. So these are all the libraries. So we need pandas to structure our data and then play with it. It's like you create a data frame with pandas and then play with that data frame to get the answer that you want. Matplotlib is for data visualization. Seaborn is a new Python library that I'm using, so it's also for data visualization. So NumPy is like to do all the mathematical operations like matrix multiplication, division, statistics, and all those. So and then we are using this standard scaler from sklearn. So this is to get all our data in single scale or uniform scale. So that's what this line of code is going to do. So it's going to get standard scaler from sklearn pre-processing so that we could scale the data in such a way that it makes sense and easier to do the calculation. So see, okay, so we just don't have to worry about that one. So now what we're going to do is we create a pandas data frame with the data and the website link here. So this is same as this one here. I'll put the link to this one, the description of the video, so that you could also start playing with these data. Okay, and these are all the features and labels. So this is what we're going to predict. It's not actually it's actually a numerical value, so it's not just 0 or 1 or like A, B or C. Okay, it's actually numerical value that we're going to predict, so it's never going to be like 100% accurate or 99% accurate, but still we try to get closer to a value that actually help us make a decision. Okay, so yeah, you have to know this to understand what's actually happening inside the age index that I said in the last video, the proportion of non-retail business acres per town. CRIM, this is the per capita crime rate by town. So all these things you consider like when you go buy a house. So yeah, so these are the consideration they are making. As a user, the user should know before they make a decision on buying a house. Okay, hopefully I'm making sense. So okay, so now let's go ahead and print the data. Print. Actually, I'm using Python 3.6.2, the so-called latest version. So I have to put all these brackets. Before this, I think I was using Python 2.7, where I don't have to put these brackets. So these are our data. So it's all truncated data. So if you see this, because data frame pandas usually truncates the data so that it won't take up a lot of space. Okay, it's actually you have 14 columns and 506 rows. So you have 13 features and one label, which is a price. So if you go ahead and count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 columns. Okay, and the last one is the price. Okay, makes sense. Makes sense. So it's actually $24,000 if it says 24. Okay. Let's close this now. We have imported our data. So now we name the columns in a data frame. Okay, it's same as a JPEG file that I'm flashing to you guys all the time. So it's exactly same as this one. Crime rate, ZN, index, chars, knock, row, all those things. Yeah. So now I don't want to close this one. Okay. So now let's comment this out. We no more need this one because we're sure that we actually are importing data from the internet, so we don't have to worry about that one. So now let's go ahead and print df.head. So it's gonna print the header with few rows of data. Okay, that's what it's supposed to do. Let's see whether it's doing what's supposed to do. So it's actually printed 5 rows of data with all these 14, yeah, whatever it is, the features and labels. This is the price how much, the median value, yeah, in thousand. So it's actually 24,000. It's actually a median value. Okay, not bad. So now we are going to use this Seaborn library that we have imported. So in order to install that, you can go pip install Seaborn, but before that you need SciPy. So ensure that you install SciPy. If you want to install SciPy, you have to install NumPy plus ML. So if you go search Python binaries, the first thing that pops out is this one. So here you could find all the libraries that you want. Okay, so you know how to do it. So maybe I'll put the link to this website in the description. So now you install Seaborn 2, I assume. I presume. Okay, I don't assume. Now let's create the graph. Okay, I surely copy paste. Okay. So what I'm doing is set the style is going to be a white grid and the context is going to be of a notebook type context. So these are all the arguments that I'm passing to this set function in this Seaborn library. Okay. Then the columns that I'm considering, it's actually an array basically. So I want to take LStat, index, Knox, RM, and median value. That's what it is. So I'm taken. I've taken these four labels. I mean, four features with this label, one label. Okay. And what I'm gonna do, the next, I'm gonna define the size of the plot and also specify the column pair plot. So what it's actually gonna do is it's going to. I just ate something. That's why my there was a burp. So I apologize for that. So LStat is going to be compared in graphical form with index, Knox, RM, and median value. In such a way, all these five like criteria will be intercompared. Okay, that's what's going to happen. So I've specified the size as a 2.5. It's like a graph size. So then I go, I say like plt.show. Then it shows you the graph. So this graph is pretty much useful, not just for this one. So whatever data analysis that you do, so this will be pretty much useful. It's like it's gonna like give you a visual picture of what's actually happening. So what kind of data you're dealing with. So this it makes sense to create or model or design an machine learning data frame or whatever, like with the data that you're designing it with. Okay, so it's like just try to have a look at this one before you dig deeper and try to make sense out of your algorithm with the data that you are having. But let's say your data is not at all related to each other, and then if you try to like make some sense with your output, then it's not going to make sense at all. No matter how hard you try and refine your algorithm, just try to have a look at the data before you start playing with the algorithm, whether it actually makes sense to use the whatever model that you're going to like thinking of using or designing. So if you look, these are like negative. Okay. So now, okay, it all looks fine. So close this. Close this. And let's go to the next one. what I'm gonna do is, I'm gonna grab the correlation coefficient using numpy, which is what's happening here. So correlation coefficient of the columns value which are being transported, because transposed, okay, is like open an Excel sheet just to give an example. Yeah, it's open. Okay, so A, B, C, D, E. So I have these data set. So what I'm gonna do is I'm gonna write A, B, C, D. Okay, A, B, or where they be here? B, C, D, E. So I'm going to calculate the correlation coefficient of this one with this one. So that's what actually happening. That's the reason why I'm transposing this. And then the font scale is the parameter that I'm specifying for the data that's going to be displayed. That data is going to be the correlation coefficient. Okay. And then it's going to be a heat map. Yep. So you actually can't see this. Now you can see this. So have a look at this one, copy paste the code. I don't want to understand what this means till I face an error. So I never face an error. Then I could beautifully import the data into this one, whatever data that I want, and then see whether it makes sense. So now this is from Seaborn. So and this is the output of those few lines that we copy pasted recently. So this is the font size that we're defining. So this lstat, and then index. So you have all these here. So yeah, it's at the below. So shit. Yeah, I maximize this. So lstat. So then you calculate the correlation coefficient between this one and this one, this one and this one, like all five amongst themselves, using numpy correlation coefficient function. Okay, and you pass your data as an argument, and then you set the font, which is could be this one and this one, and then you also specify all these what the labels. So you also specify the calls as your labels. X tick your calls which are your label, and y tick labels also your columns. Okay, so it's actually a heat map. So based on your value, so it's gonna like um, it's gonna like it's gonna like visualize it accordingly. Okay, so now you can see. So the more positive correlation are here. So here it's all positively correlated, and here it's all positively correlated. So and here are negatively correlated. Okay, so there is some correlation irrespective of the direction in which it's correlated. So you could use linear regression for this. So yes, we could use linear regression for this. So we make that conclusion here, then end the video here. So we'll keep doing this in the next video. Thanks for watching this. Talk to you guys in the next video. Bye for now.